Let's take a look at this example. We're supposed to find voltage across resistor RL. What I would do first, I would convert this voltage source to the current source. So I would say that this is going to be my I1. I1, okay, so is equal voltage source 1 over R1, which is equal 16 volts over 8 kilo ohms. This is equal to 2 milliamps. Okay, so this is my I1. Next, I would redraw the circuit. Because I have positive terminal at the top and negative terminal at the bottom, I would draw my current source like this, going up. And this is my ground. Okay, this is going to be my resistor R1. This is my I2. Okay, current source I2. This is my current source I1. This is my R2. These are my terminals XY. And this is my resistor RL. Okay, so first what I would do, I would find I total. I total is equal I1 plus I2. Why I'm going to add them up? Because both of them are pointing up. So we have I1. I1 is equal to 2 milliamps plus I2, which is equal to 5 milliamps. So I total is equal to 7 milliamps. Okay, so next we're supposed to find the total resistance in the circuit. Okay, I'm going to also include my RL. So I have R total is equal 1 divided by 1 over R1 plus 1 over R2 plus 1 over RL. This is equal 1 divided by 1 over 8k plus 1 divided by 6k plus 1 divided by 4k. This is equal 1 divided by, open parenthesis, 1 divided by 8 exponent 3 plus 1 divided by 6 exponent 3 plus 1 divided by 4 exponent 3, close parenthesis, equals 1.84 kiloohms. Okay, so this is my total resistance. If I want to find VL, I'm supposed to find VXY. VXY is equal to VL. This is also equal to V2, right? So what we're supposed to do, we're supposed to simply multiply the total resistance I total times R total. Okay, so I total is equal 7 milliamps times R total, which is equal 1.84 kiloohms. Why I'm doing that? Because my circuit, right, I would draw like this. This is my I total, okay, and this is my R total, okay. So these are the terminals XY. So I total times R total will give me VXY. And this is equal 7 exponent 3 negative times 1.84 exponent 3. This is equal 12.88 volts. Okay, so we found Vxy. Vxy is also equal to VL, so we found VL. Now we can find PL. PL is equal VL to the second power over RL. This is equal 12.88 volts over RL, which is equal to 4 kilo ohms. This is equal 12.88, of course, to the second power. Divided by 4 exponent 3. This is equal 41.47 milliwatts. Okay, so this is my PL. Next, so it was my PL. Next, I'm supposed to find I2. Okay, I2 is equal V2 over R2, where V2 is equal to Vxy or VL. This is 12.88 volts over R2, 6 kilo ohms. This is equal 12.88 divided by 6 exponent 3. This is equal 2.14 milliamps. Okay, so this is value of my I2. Next, we're supposed to find P1, power at resistor R1. So we have to get back to the original problem and realize that the voltage across resistor R1 plus the voltage Vs1 is going to give me Vxy. So I can write that Vxy is equal voltage source 1 plus VR1. Okay, so what I'm going to do, I'm going to try to find voltage across resistor R1. So what I would do, I would move it to the left side. So I'm going to have VR1 equals Vxy minus voltage source 1. Vxy we've found is equal 12.88 volts minus voltage source 1, which is equal 16 volts. Okay, so VR1 is equal negative 3.12 volts. Okay, so this is VR1. Okay, let's check it. So I have 12.88 minus 16 equals negative 3.12 volts. So this is my VR1. If I have VR1, I can find P1. P1 is equal VR1 to the second power over R1. So I have negative 3.12 volts to the second power over R1, which is equal 8 kilo ohms. This is equal 3.12 negative to the second power divided by 8 exponent 3. This equals 1.21 milliwatts. 1.21 milliwatts. Okay, so we've found VL, we've found I2, we've found P1, we've found PL, so we can say that the problem is